Hello students, welcome to the lecture series by Center for Distance and Online Education, Bharati Vidyapit, deemed to be University, Pune. I am Dr. Suvarna Patil, the facilitator for the subject operating system for BCA course. So let's start. In the last session, we have learned up to types of operating system. Let's move ahead. Different views of operating systems. Here, the operating system provides you two views. The first is command language users view and the second is system call users view of operating system. Now in command language users view, you can see the operating system commands are basically system specific. The commands, the syntax, they differ from system to system. The functionalities may be less varied, but the commands differs system to system. There are some commands like for logon and housekeeping commands to log in into the system and log out from the system, such as login and exit. There are commands for program activation and controlling of a program, which allows program to be loaded and executed. The commands are like run and load. There are commands for file management. They are usually provided like create, delete and open. There are some commands they support for system management. They are reserved for system manager and maintenance personnel. The second set is system call users view of operating system. Here the system and application programmer, they access the operating system services from their programs. They are using a system call to access the services. The system calls are also called as a API, application programming interface. So system command, which is given by the command language user, they are executed as a series of system call. System call, it actually provides a control over the system operations and it provides a direct access to the hardware like input output devices. The next is structures of operating system. There are various structures they are supported in operating system. We have monolithic operating system structure, layered operating system structure, virtual operating system structure, client server operating system structure. Let us discuss one by one. The first is monolithic operating system structure. It is the oldest structure used for operating system. Mono means single. So this operating system runs as a single program in kernel mode. The operating system is written as a collection of procedures and it is integrated together into a single large executable program. Here, each procedure can call any other procedure without any restriction. So here pre-compiled procedures are integrated together into a single executable file using the linker. Here no information hiding is done as every procedure is visible to every other procedure. So a main program is requesting to a service procedure. The service procedure may carry out the system call. It will give a call to a system call and the set of utility programs, they support the service procedures. So here you can see these three parts: main procedure, then we have service procedure and then we have a utility procedure. But here each procedure can call any other procedure without any restriction. There is no any information hiding. There are no any rule for the operating system. This is about monolithic OS structure. The next is layered operating system structure. As you can see, it is organized as a hierarchy of layer, one above the other. The system is made up of basically 6 layers. The layer 0, that is last layer. Layer 0 is responsible for allocation of processor and switching among the processes. So anything about the process management is done at this layer, layer 0. Layer 1, it is responsible for memory management as well as disk and drum management. It allocates the memory to process. The layer 1 takes care of swapping and other memory management functionalities. The layer 2 is about process and operator communication. So here this layer is responsible for communication between the process and the user, the operator. The layer 3 that takes care of input output management regarding any input output devices connected to your operating system, to your machine. Layer 4, here the user programs are loaded. So whatever user programs you are having on your operating system, they will be residing at the layer 4. At the top layer, layer 5, we have a system operator. We can say the user of the operating system or the operator of the operating system. This is the 6th layered operating system structure. They are organized as a hierarchy of layer, one above the other. Every layer is having a different set of functionalities. Okay. The next is virtual machine operating system structure. Here the core part of the system is called as a virtual machine monitor. It runs on a bare hardware and it provides the several virtual machines to the next layer up. On the original VM70 system, it runs on OS-370 operating system, while the bare machine it run on the conversational monitor system, that is for interactive time sharing users. When CMS executes a system call, the call is tapped to the own virtual machine, not to VM370. The CMS then issued a hardware input output instruction to carry out the system call. Here JVM, Java Virtual Machine, can be the best example for this virtual machine operating system structure, where we say Java is a platform independent language. It needs a JVM to be installed to execute and to support the working of the Java program. The last is client server operating system structure. Here the idea is to distinguish the system into two classes. The processes are divided into two classes. One is server side, each of which provides some service to the client, and the second slide is a client side which is using the service. So server class of process, they are providing a service, and client is a set of process which are using the service of the server. This model is also known as a client server model. The communication between client and server is possible with the help of message passing. To use the service of the server, the client process sends a message or a signal to the appropriate server saying that what it wants. Then the server, it does the work and send the answer, send the reply back to the client. So here server runs on different computer and they are connected by LAN and they can communicate with each other by passing the messages. You can see here there are 4 machines connected in the network. So this is providing a client server architecture with the help of client server operating system structure. The next is user operating system interface. Whatever is your operating system, what is the interface provided by the operating system, that we will discuss here. We have one command line interface that we call as a CLI, and we have other interface which is called as graphical user interface GUI. Now command line interface, it is the interface in which user can communicate with the program, with the operating system by writing commands at the command line. If you take example of MS-DOS operating system, it is providing you CLI interface, command line interface. Here the user will type the command at the command prompt. So it gets a C:" prompt. At that command prompt, the user will type the command. The CLI will not have any menu. It won't use any mouse. It won't use any menu. So user type the command which should be executed, and then it press the enter button. As the enter key is pressed, the command is executed and the result is displayed on the output device. So CLI is a primary means of interaction with most of the computer system. Then after some years we had a graphical user interface, GUI. Now most of the interfaces, they support the graphical user interface. Here you interact with the computer with the help of interactive graphical controls. You can use a keyboard, we can use a mouse, you can use a touchpad, input and some graphical element to interact with the system. With the help of mouse, you can control, you can interact by using menu, using icons, buttons, scroll bars. We have forms and some other category. Here GUI is comfortable for any user, so it makes the system very user friendly. Nowadays GUI is used in computer as well as mobile phones, the digital camera, the camera. So it enables the user with the less, he can have a less knowledge of a computer to use the computer software. Even the entire operating system can be used easily with the help of GUI interface. The system calls provided by the operating systems for many purposes. For process creation and process management, we can have a system call like abort, we can have a system call create, terminate, allocate and free the memory. We have a system calls provided for operating system for memory management. The system calls are provided for accessing a file, directory and file system management. The calls are like create, open, close and delete, as well as reading of a file. The OS provides a system call for device handling, input output devices handling. It provides system call for protection mechanism as well as for the networking mechanism. So as we have seen, a system call is a way for a program to interact with the operating system. A computer program makes a system call when it makes a request to the operating system's kernel. System call will provide a service of the operating system to user program with the help of your API. So here system call are the only entry point to the kernel system. All the programs needing resources, they must use the system call. As a case study, we'll discuss here Unix operating system in short. Unix is a multi-programming operating system. It was first developed in 1960s in the form of multics. In 1969, Ken Thompson and his team, they have released the first version of Unix, which was known as Unix, at AT&T Bell Lab. In 1991, the Linux version was released. When you talk about Unix, is basically having a CLI command line interface, and when you talk about Linux, it's having a graphical user interface. There are many different versions of Unix available like Sun Solaris, like GNU/Linux and Mac OS. This is a onion shaped structure of Unix operating system. We can see here we have a kernel here, we have a shell here and we have application programs here. So Unix operating system is made up of three parts basically: kernel, shell and the programs. The inside layer is a hardware layer, and above that there is a kernel, above that there is a shell, and above that we have a application programs. The kernel is a heart of Unix operating system. It is a software that provides the interface between the hardware and the user. It handles the process as well as memory, file, device and network management for the operating system. Kernel is responsible for ensuring that all the system and the user tasks are performed concurrently and correctly. The role of shell is acting as an interface between the user and the kernel. You can see the position of the shell here. This is the kernel and this is the application program, whether user is using this program. So shell is lying between kernel and the user application program. When the user logs in, the login program checks the username and password, and then it starts the program, which is called as a shell. The shell is a command line interpreter. It interprets the commands that user is typing and it arranges for them to carry out the process. Commands and utilities, they are lying at the layer of the application program. They are the various commands, utilities which you can make use for your day-to-day activity. We have utilities or programs or commands like cp for copying the command, mv for moving the file. We have a cat command, we have a grep command which is supported in Unix or Linux. So there are more than 250 standard commands supported in Unix or Linux. Thank you.